All right, philosophers, formal fallacies, part 2. We'll start with a little review. Excuse me. 4-term fallacy. There must be only 3 terms. Remember, we have 3 propositions we're worried about, 2 premises, and those 2 premises come together to prove a conclusion. There is a major term which shows up in one of the premises, a minor term which shows up in the other premise, and the middle term which shows up in both premises. And the middle term is what connects those two so that you can connect them into the conclusion. If you have more than 3 terms, then there will be no connecting of those, because one of them is not, the middle term is going to be gone. Undistributed middle fallacy. The middle must be distributed at least once. And remember, this is because if you're going to connect them, you kind of have to know at least somewhere how in the pictures how big the middle term is, right? How big that circle is. But really, you need to know how it relates to one of them at least perfectly well, so that you can see how that would connect to another one. Illicit process fallacy. Anything that is distributed in the conclusion must be distributed in the premises. So anything that you say at the bottom is distributed, you better say that at the top is distributed as well, right? You can't get what you don't have, right? So if you don't have it up in the premises, you can't get it in the conclusion. And rule 4, conclusion always follows the weaker premise, and the weaker premise here meaning like the sums, right? If there's a sum in the premises, then there better be a sum in the conclusion. And if there's a no in the premises, there better be a no in the conclusion. All right, let's get into our first fallacy of the day, rule number 5. All right, no humans are angels. No angels are God. Therefore, no humans are God. Now, we would diagram it like this, right? No humans are angels. All the humans are outside of all the angels. And no angels are God. All the angels are outside of God. Now, but if you look at this, you might think, you might kind of see why you can't really get a conclusion out of this, because no humans are angels, but I don't know where outside of humans angels is, and I don't know where outside of humans God is, right? In these circles, right? I know. So although this makes sense, although these 3 propositions are true, this is an invalid argument, and I'm going to switch God with construction workers. So just these 2 right here, I'm going to switch out with construction workers, and then might see how it's a little bit different, how it does not make sense. No humans are angels. No angels are construction workers. Therefore, no humans are construction workers. And here's exactly our problem. I said angels are outside of humans. Angels are outside of construction workers, but I don't know where humans and construction workers are in relation to angels, right? So the problem here is that we have 2 negative premises. And if you have 2 negative premises, then you can't get a conclusion. Nothing comes from nothing. So rule number 5, exclusive premises. No conclusion follows from 2 negative premises. I don't know what exclusive premises mean. That doesn't sound like it makes sense with this, but just know that no conclusion follows from 2 negative premises. All right, next one. Some desserts are cookies. Some cookies are chocolate chip. Therefore, some desserts are chocolate chip. Sounds reasonable, right? Here's how you diagram it. Sounds totally reasonable, and it's totally fallacious. So here's the problem in this one. You say some desserts are cookies, right? So we know that they meet somewhere. In fact, let me draw it over here. Some desserts are cookies. So this will be D, right? And we know we're talking about this action right in here. And some cookies are chocolate chips. But when you say that, like, you don't know if chocolate chip is over here. CH for chocolate chip. Normally, you're not allowed to use 2 letters to symbolize something, but I'm breaking the law. All right, so you don't know if it's over here. You don't know if chocolate chips is over here, like it is, like it's set up right here, because here they overlap. But if this were the case, they wouldn't overlap. Let me change. Let's see. Snickerdoodles. Yeah, let me change desserts with snickerdoodles. All right. So some snickerdoodles are cookies. Some cookies are chocolate chip. Therefore, some snickerdoodles are chocolate chip. All right. Now, snickerdoodle chocolate chip cookies don't really exist. Although I have to say, once I had a logic student, I presented this exact same example. Next day, she came in with cookies, and I thought, oh, how sweet. I can't believe she's bringing cookies to class. And they were snickerdoodle chocolate chip just to spite me. And it was hilarious, so I give it up. That was, and they were delicious. That sounds nasty, but they actually were pretty good. So, but let's just pretend there are no such things as snickerdoodle chocolate chip cookies. All right. Now you can see snickerdoodles on this side, chocolate chips on this side. So the problem here is because I have two sum statements, right? I don't know, I don't know enough about these to connect them. Another problem you might see here is that that there is no, if I have two sum statements, then here the middle term is never distributed. Right, so this has already violated one thing, but yeah. So because of this two sums, you can't get anything out of it. So rule number 6: no conclusions follows from two simple particular premises. Simple particular premises are just the sum premises. And finally, all NFL players are football players. Some NFL players are saints. Therefore, some football players are not saints. This last one is really hard for me to figure an example that actually sounds legit, because they always, like, I don't know how it sounds to your ear, but to my ear, this argument sounds off. Something sounds wrong with it. But these propositions all are true. So all NFL players are football players, right? So there it is. Some NFL players are saints, right? And remember, that's true. Like, some NFL players are saints. I drew it like this. That's the way that things really are, even though usually we draw it like this, right? But I drew it like this just so you can kind of see, like, that's the true way it is. All saints are NFL players. Therefore, some football players are not saints. Yeah, I don't know. I'm going to switch, what is it? Saints with use helmets. Alright, so that's the only thing I'm switching right here is saints right here with use helmets right here. Alright. All NFL players are football players. Some NFL players use helmets. Therefore, some football players do not use helmets. Now notice, some NFL players use helmets. It also is the case that all NFL players use helmets, right? But this statement right here is still a true statement. It's literally true, right? If I said, no, false, it's not true that some NFL players use helmets. Well, no, it is true that some NFL players, in fact, all of them happen to, right? So this is literally a true statement, even though it doesn't sound like a true statement. And NFL players, inside of football players, use helmets. Yeah, so this is, something's wrong here. What's wrong here is that you have two yeses, and down here you have one no. All right, so you can't get a negative conclusion from two affirmative premises. That's the problem here. So rule number 7: no negative conclusion follows from two affirmative premises. And with that, it's practice time. Let me see here. Let me get my AirPlay going. Bam. Is that? It's not working yet, is it? There you are. Alright, there it is. So, first practice problem. So we're going to symbolize these examples, and we're going to say whether or not they are valid, and if they are invalid, what fallacy has been committed. In fact, let's go back here and we'll pull up our rules so that we're sure that we know. And remember, more than one fallacy might be committed. But as long as you know that one fallacy was committed, it doesn't really matter if you get all the fallacies. And that's not really, as long as you know that it's fallacious. The first one: all of the buildings on the street are brick. So we'll say all, I'll say U for buildings on the street. Whoa. All U are brick. Some bricks are not red. Some R is not E. Jeez. I should have saved R, but sadly I didn't. Therefore, some U is not E. Alright, let's go through our rules. All U is R, some R is not E, therefore some U is not E. I look at rule number 1, 4-term fallacy, U, R, and E. We're good. 3 terms. Undistributed middle fallacy. The middle term is R because it shows up 2 times. Oh, no sir. R is undistributed in both cases. So this is rule number 2, undistributed middle fallacy. I'm going to keep going just so that, you know, like I said, you don't have to figure out every single one, but just to make sure that we see them all. Illicit process fallacy. E is distributed down here. E is distributed up here. That's okay. I mean, that's good. Conclusion always follows the weaker premise. Some up here, some down here. Sweet. No conclusion follows from 2 negative premises. I have a affirmative one here, so yeah, so I'm good on that one. No conclusion follows from 2 simple particular premises. I have an all here, so I don't have to worry about that one. No negative conclusions follows from 2 affirmative premises. I have a negative premise right here, so I'm good on that one. So the one this commits, though, it only commits rule number 2, undistributed middle fallacy. All right. Some flowers are red. Some F is R. Oh jeez, I got a little stuff on my iPad. I apologize about that. Some red things are beautiful. Some R is B. Therefore, some flowers is beautiful. Alright, now let's see if we've committed any fallacies. I can already see we have. 4-term fallacy, only 3 terms, we're good. 4-term fallacy rarely gets committed. I mean, really the time that it gets committed is like we talked about last time, when you equivocate, when you use a word one way and then later on in the argument you use it in a different way and you don't recognize the difference. So that rarely do you have a 4-term fallacy that's super obvious. Oops. Undistributed middle fallacy. R is the middle term and it is undistributed. So this one was rule 2, this one's rule 2, but this one also actually has another rule that it violates. Illicit process fallacy. Neither F nor B are distributed, so we can't commit the illicit process fallacy. Conclusion always follows the weaker premise. Some is up here, some is down here. Okay, good. No conclusion follows from 2 negative premises. I don't have any negative premises, so that's good. No conclusion follows from 2 simple particular premises. That's the one we commit to. We have 2 sums, and then we can't get anything from 2 sums. Finally, rule 7, no negative conclusion. Well, we don't have a negative conclusion, so we're okay on that one. So this one, rule 2, and what was it? Rule 6. You know, like I say rule 2 and rule 6, but honestly, like I don't remember them as numbered. I'm just writing so I don't have to write down those long names. All dogs are mammals. Ooh. All D is M. Oh my gosh, I'm having all kinds of problems. It's like every night I'm doing something jacked up with this thing. All birds are mammals. All B is is M. So no dogs are birds. Therefore, no D is B. All right. Let's look at our rules. First one, 4-term fallacies. There's no 4 terms. We're good. Next one, rule number 2 was the undistributed middle. At M is the middle and M is undistributed. So rule 2 here. I know that it's already violated something else too. So rule number 2 is one of the problems. Illicit process fallacy. D is distributed down here. It's also distributed up here. B is distributed down here. It's also distributed up here, so we're okay on that one. Conclusion always follows a weaker premise. Yeah, we don't have any weak premises, so we're good on that. No conclusion follows from 2 negative premises. I don't have any negative premises, and actually that is the problem, because rule number 7 down here, no negative conclusion follows from 2 affirmative premises, and I have 2 affirmative premises and a negative conclusion. That equals problem number 7. Oh, and rule number 6, no conclusion follows from 2 simple particular premises. I don't have any sums up here, so I'm okay on that one. Alright, so rule 2 and 7, those are the ones that are violated. Next one, no dogs are birds. Oh, that's incredible that I can continue to make the same mistake over and over again after not doing it this entire time. No D is B. No B is M. So, therefore, all D is M. I don't know if any of these are valid. It looks like none of them are. Let's see here. Rule number 1, four-term fallacy. There are only 3 terms. Rule number 2, undistributed middle fallacy. The great thing about no's is that both of these things are distributed. So if you have no in the premise as a premise, you know you have you don't have an undistributed middle, because there's got to be a middle term in both premises, and the no takes both of these as distributed. So that makes it pretty sweet. Rule number 3 is illicit process fallacy. D is distributed down here, but it's also distributed here. Okay, good. M is not distributed, so I don't care if it's distributed or not up here. It actually happens to be distributed, so it doesn't really matter. Rule number 4, the conclusion always follows the weaker premise. There's no sum up here, right? Rule number 5, no conclusion follows from 2 negative premises. All right, so rule number 5 has already been violated. We have 2 negative premises, and nothing comes from that. Rule number 6, no conclusion follows from 2 simple particular premises. I don't have any sums, so I don't really care. Rule number 7, no negative conclusion follows from 2 affirmative premises. I'm good on that one. Actually, conclusion follows the weaker premise. Since there's a no up here, there should be a no down here. It's not just the sums. So rule number 4 as well. That's right? So conclusion follows. Yeah. All right. All dogs are hairy. All D is H. I really have to have more interesting examples than these. These are off at the top of the dome, so. Some hairy things are not birds. Some H is not B. Therefore, some D is not B. Alright. Some H. That's an H right there. Alright, let's do our check. 4-term fallacy. We're good on that one. Undistributed middle. Yeah, get off. Undistributed middle. Oh, undistributed middle. Gosh, that just keeps popping up. So this violates number 2. H is up here twice, so it's the middle term, and yet it's undistributed here, undistributed here. Illicit process fallacy. B is distributed down here, but it's also distributed up here, so we're okay. D isn't distributed, so we don't care what it is. It actually is distributed up here too, so we're double fine on that one. Rule 4 is what? Weaker premise? Yeah, conclusion always follows the weaker premise. I have a sum up here, sum up here, down here, not. Okay, good. No conclusions follows from 2 negative premises. I have a positive, affirmative premise, I should say. No conclusion follows from 2 simple particular premises. I have an all, so I'm okay. And no negative conclusion follows from 2 affirmative premises, and I have a negative here, so that one's okay. All right, so rule 2 is the only one that is violated. Oh man, that's a lot. Okay, well, let's continue. All dogs are canines. All D is C. Some dogs are well fed. All dogs should be well fed. Some D is W. Therefore, some C is not W. This is one of those that it's so hard to find one that makes it sound like legit, but it's not legit. So let's check it out. Rule 4-term fallacy. There are only 3 terms. Fine. Undistributed middle. The middle term is D because it shows up twice, and D is distributed right here. Excuse me. Rule number 3, illicit process fallacy. W is distributed down here. Oh, it's not distributed up here. So we have rule number 3 violation. 4, conclusion always follows the weaker premise. I have a sum here and I have a sum down here, so I'm okay on that. No conclusion follows from 2 negative premises. I don't have any negative premises. I'm fine with that. No conclusion follows from 2 simple particular premises. I don't have 2 simple particular premises. I have 1 simple particular premise and then 1 universal one. No negative conclusion follows from 2 affirmative premises. I have 2 affirmative premises and a negative, so this is rule 7 as well. I think we had a rule 7 up here too, right? Yeah. Oh, wait. Shoot. Alright, I got this one wrong. Sorry, I don't know what I was doing. No birds are mammals. No bee is M. Oh, that's changing the game right there. I'm gonna have to go back here and redo this. Hope I don't know if you caught that or not. Hopefully you saw when I do an all there that I still did it right. If that had said all, I wasn't really even paying attention. All right. So let's do this one again. All D is M. Four-term fallacy. No. Right now I could turn back and redo this video, but we're powering through because we're strong. Undistributed middle. Middle term is distributed. There's a process. D is distributed. D is distributed. B is distributed. B is distributed. Sweet. Conclusion always follows a weaker premise. No. Alright, good. No conclusion follows from two negative premises. I actually have a negative premise right here, so I don't have that problem. No, I'm sorry, no, that I have an affirmative, premise, so that's not a problem. No conclusion follows from two simple particular premises. I don't have any simple particular premises. And no negative conclusion follows from two affirmative premises. So I'm not actually violating Rule 7 or Rule 2. This one is valid, guys. Hooray. Valid. One of them that's valid. That's right? All dogs are mammals. No birds are mammals, so no dirks are... Yeah, and it makes sense just intellectually. Alright, let's do the next one. No B is R. No R. Wait. Which people is. Oh, dang it. Is. Let's say U for butchers. Therefore, no B is U. And this one, I already see why it's wrong. Because we have three no's, right? So, like, if you write no B is R, and you write no R is U, you can draw U over here, you can draw U over here, right? So, I already know this one, why it's going to be wrong. Doesn't have four terms. Since these are all three no's, then everything is distributed here. So, the distribution problems are out the window. No, the conclusion always follows the weaker premise. I have a no here, and I have a no here. Fine. No conclusion follows from two negative premises, and that's the problem right here. So rule number 5. 6 is no conclusion follows from two simple particulars. There's no sums, so I'm okay. And finally, no negative conclusion follows from two affirmative premises. That's not a problem because I have two negative premises. So rule number 5. Oops. Charles with the iPad. That's... you got to get a better name for it. Oh, I just accidentally turned it off. No. Come back. Call it Excalibur or something tough. Or Gem in the Holograms. Some S is U. I'm not going to watch that movie. That looks so terrible. All P in the quad. All people in the quad. All P in the quad. Sounds disgusting. Is S. Therefore, some U is not people in the quad. That's right? Yeah, that's right. All right, so four-term fallacy, no. Illicit process fallacy, P is distributed down here, but it's also distributed up here, so I'm okay on that. Undistributed middle, S is undistributed. Oh, undistributed middle, so sad. That was rule 2, by the way. Gosh, I keep doing that. Did that not show up? It didn't show up. Wow, and then it showed up later. Guys, there's a ghost in my iPad. Rule 4. What was it? Sums. Yeah, I have a sum here and a sum here, but I have an all, so I'm okay on that one. Oh yeah, conclusion always follows a weaker premise, so that wouldn't... I have a sum here, I have a sum here, that's okay. No conclusion follows from two negative premises. I don't have any negative premises. No conclusion follows from two simple particular premises. I have an all here, so I'm okay. No negative conclusion follows from two affirmative premises. I have a negative conclusion down here and two affirmatives. So rule number 7 has been violated as well. All people are aware of the fact that dogs are the greatest pets. Now, all people are aware of the fact that is a bunch of junk, right? What is being said is really dogs are the greatest pets. So all D is G, greatest pets. They are the most loyal. Oh, you know what? Oh no, hold on a second. Hold on, everybody. I'm about to blow your mind right here. This first statement right here is actually oh is actually the conclusion, and here's why. Um, Notice people. It says all people are aware of the fact that dogs are the greatest pets. They are the most loyal, and the most loyal pet is the best pet. So, right back here, you're getting the reasons for why dogs are the greatest pets, right? So, if you're getting the reason, those are the premises. If you the thing that you're given the reasons for, that's the conclusion. So, all D is G. So, all dogs are most loyal, M. All most loyal is greatest pet. Therefore, all dog is greatest pet. All right, so that's what we're working with. There are not four terms on there. The middle term M is distributed at least once. D is distributed down here. It's also distributed up here. I'm okay with that. There are no sums, so I don't have to follow the weaker premise. There are no negative premises, so I don't have to worry about that. I don't have what else? I don't have any sums, right? So I'm not worried about rule 6. And I don't have a negative conclusion, so I'm not worried about this. This guy is valid. Valid. And I wonder, let's see, if you were to instead of all this, let me get this out of the way. Oh, like that. If instead of this, you were to have made the mistake of saying this first one, well, let's still erase that. Saying this first proposition was the premise. Let's see if that would have been valid. All dog is G, greatest pet. No, you would not. All dog is most loyal. Therefore, all most loyal pet is greatest pet. You would not have, this would have been invalid, and the reason is because M is distributed down here, but it's not distributed up here. So it's important to pay attention to what is actually being claimed, what is trying to be proved, and what is being used to prove that thing. All right, last one. Nobody is perfect. I am nobody, therefore I am perfect. Once again, I've turned off my iPad. There. Nobody is perfect. Now, so when you say nobody is perfect, though, that is you. What can I say? No, I guess you literally mean that. But if you say I am nobody, notice that you don't mean nobody in the same way as this. Nobody here means no person, right? So it's something like this: no person, no. Oh, they both start with P-E. I'm gonna say no person, N. No N is T. Perfect. I. All of I is, and then this nobody will say is Y. Nobody. Therefore, all I is perfect. All right. So this is a four-term fallacy, NTIY. Right? There's no middle term to connect these two. If you drew them out, it would say no N is T, and all I is Y. All I is inside of Y. However, this guy right here, you don't know where it's supposed to be. It could be right inside. Oh, I didn't mean to take that guy with me. Let's see here. Let's undo that. I'm not sure if I'm going to get this. No, I'm not going to get it. Well, anyway, the I and the Y could be drawn inside of the T, inside of the N, right? Outside of both of them, you have no idea. So this is a four-term fallacy. If you were to write it literally, right? If instead you were to say all I am nobody, and pretend that these two nobodies actually mean the same thing, right? If you were to do something crazy like that, what would happen? Let's find out. Would it be valid? And would you have made a big mistake? I'm gonna symbolize nobody as an N. I'm not gonna say no person is perfect. I'm gonna say all nobody is perfect. All I is nobody. Therefore, all I is perfect. Right? And that is actually a valid argument right there. So if you didn't catch that, then this would be a problem. By the way, one last thing. I don't know if some of you have been worried about this, but sometimes you see stuff like "I am nobody," and you see that this is a negative thing, right? And you think, "Ah, oh, geez, like um, is it the case that I should say no, I am a person, or should I write I am all I am an N?" Um, Usually, that I should say no. If it's legit, that's not going to be a problem, right? So, for example, let me find an empty space. I'll just right here. If I want to say something like, oh, geez, off the top of my head, some people don't like. What don't people like? Some people don't like Brussels sprouts. They are terrible. It tastes like earwax. Not that I've ever tried earwax. Some P is, you could say some P is not a Brussels sprout lover, or you could say some P is a non-Brussels sprout lover, right? And both of these, as long as you keep it consistent, are going to be just fine. Because like, let's say you say some people don't like Brussels sprouts. All quiche has Brussels sprouts, so some people don't like quiche, right? So uh, as long as you let's see, so some people don't like Brussels sprouts. Oh yeah, now if you're gonna say all quiche is a thing that has Brussels sprouts in it, actually that's not even the same term, so that wouldn't even be a problem. That wouldn't even apply in the first place. Yeah, just know that like I guess I don't have a good example off the top of my head, but just know that as long as you keep the terms consistent, as long as you either are saying Brussels sprouts, Brussels sprout lover, or non-Brussels sprout lover, then you are going to be everything's going to be okay. And that's it for this video.